We're still discussing random variables, which we said were variables that can take on several realizations, and each of those realizations has a likelihood of occurring. Random variables help us represent uncertainty in the processes and systems that we observe. We looked at discrete random variables whose realizations come from a discrete countable set. Oftentimes, the realizations of a discrete random variable are integers. For example, the number of cars that arrive at the intersection of Jenkins Avenue and Lindsay Street in the next hour, or the count of defective electronic components in a batch of 50. In this unit, we describe the other type of random variable, the continuous random variable. Continuous random variables have realizations that are measured on a continuous number line. Rather than discrete categories, we have continuous values. And there are presumably infinite realizations of a continuous random variable because there are an infinite number of values in between 2 points on a continuous number line. For example, a continuous random variable might measure the distance traveled by a package delivery van on a given day, or the lifetime of a light bulb until failure. These quantities aren't fixed. We might observe a different realization with every delivery van or light bulb, and we can create a probability distribution for those realizations. We graphically depicted the distribution of a discrete random variable with a rigid bar graph. With a continuous random variable, we often have distributions that are smooth curves. We'll discuss a few common probability distribution functions for continuous random variables in this unit, along with how to calculate probabilities of ranges of realizations.